Throughout history, fear of change and the unknown has often caused heightened anxiety to countless millions of us in the general public. But if we look closely at history, this fear is often not born out of outcomes. In fact, the past is littered with stories of change that were feared in the early stages, eventually becoming accepted as a necessity, a comfort, or an option. A perfect example of this came early in the 19th century, when electricity would become an essential tool for modern life. The masses were used to lighting candles and having open flames to illuminate the night, with little regard for the danger of fire. But for many, the idea of an entire home being electrified created a new fear of electrocution. In one famous case, it is said that even though President Benjamin Harrison had electricity installed in the White House, he and his wife would not touch the light switches for fear of electrocution, often resulting in them going to sleep with the lights on. Clearly, in the case of electricity, public opinion has changed dramatically, as is true of so many other cases of societal change. Even though initial fear, followed by acceptance, is a known phenomenon, these same old feelings are still very powerful today, especially with our modern world changing so quickly. One societal change that is occurring today that seems to be following the same path are the feelings surrounding the rise and use of unmanned aircraft systems, or UASs. For many, their only experience with these vehicles comes from media reports about them being used by the military for intelligence gathering and defense. Those images, coupled with privacy and safety concerns, is causing some to fear using them back here at home. Many on the front lines of the UAS revolution see tremendous advantages by using these devices in civil applications such as farming, package delivery, wildfire detection, border security, and numerous other uses. Only time, lawmakers, and public opinion will answer the broader societal questions. But one thing is for sure: the technical challenges surrounding these vehicles need to be answered now. Once these vehicles begin to fly regularly here in the U.S., they clearly must be able to work within our current commercial airspace in a safe and integrated way. To make this happen, the government is turning to the world's leading aeronautical organization, NASA, to help develop the framework and lay the groundwork for integration into our airspace. Coming up on this episode of NASA X, we will follow members of NASA's Aeronautics Research Mission Directorate's UAS integration into the NAS project team as they tackle the major hurdles of integrating these types of vehicles into our daily lives. We'll see how researchers are solving technical challenges as well as concerns around human factors in an effort to one day allow these vehicles to safely integrate into our society. Every day, millions of people board planes here in the U.S. For most of us who travel by air, we don't think much about all the systems in place to make our flights as seamless and easy as most are. We travel from destination to destination with little thought of all the people, equipment, and regulations put in place to make our national airspace system the safest in the world. Airports, air traffic controllers, towers, communication systems, maintenance crews, and thousands of other moving pieces, along with regulations, are all key elements that allow for relatively smooth and safe operations for the nearly 50,000 flights that take off and land in the U.S. every day. Our National Airspace System, or NAS, is incredibly robust, and in fact works so well because everyone who works within the system understands their role and the procedures that have to be laid out. But when you have a system that works so well and is so vitally important, the idea of making fundamental system-wide change can be daunting. And one of the biggest changes that will be confronting the NAS shortly is the inclusion of unmanned aircraft systems, or UASs. The FAA has strict rules outlining all aspects of piloted flight, but with no pilot inside a craft, changes will need to be made to make sure these systems are as safe and robust as possible.
Safety is always in the back of our mind, and having these systems that can be just as safe as the manned aircraft, which we have the safest air transportation system in the world. And so as the FAA takes these new technologies, introduces those into unmanned aircraft, and introduces those into the NAS, that safety will not be compromised. We are doing this and making sure that when the FAA assesses the technologies and assesses any airframe and the avionics that they have or the sensors that they have on board, that those are going to meet the same sort of standards, maybe not the same exact standards, the same sort of standards that they've established for manned aircraft. So safety is always in the back of our mind, and it underpins every decision we make and everything that we do.
The task is definitely daunting. We focus particularly on procedures and standards. So from the procedures side, the FAA has built a very, very safe national airspace system. Accidents essentially don't happen. A lot of the rationale for that is procedural. Our air traffic controllers know what they're doing, they know how to manage their airspace, and bringing UAS into this system changes things. What we're trying to do is help inform procedural development so that the FAA can take our inputs and integrate them into their new air traffic control system as they develop their next-gen infrastructure.
This is one of the reasons NASA has such a large role in the UAS integration into the NAS. NASA has decades of understanding how to build a system as complex as this into a functioning reality.
But the reason why NASA is involved is pretty much consistent with what NASA does across the board. I mean, NASA is looking for investments in research areas that will enhance the quality of life of your everyday person. And so that applies in the area of aviation. That applies to things like looking at how we can fly airplanes faster or use less fuel or do something positive for the environment while still flying over that environment. So we've been doing those kinds of things in aeronautics all along, and unmanned aircraft systems is just another new technology that has the potential to enhance people's quality of life.
NASA planners laid out a game plan to tackle the major issues involved in integrating UASs into the NAS. Their plan is to focus on 4 major technical barriers to make this transition possible. These 4 include sense and avoid, command and control, human systems integration, and integrated test and evaluation. The sense and avoid challenge is focused mainly on the see and avoid problems UAVs have because there is no pilot in the cockpit. Technology will need to be developed that will, in essence, replace the pilot's eyes with incredibly accurate radar, helping UAV pilots on the ground avoid any nearby aircraft. The command and control challenge will develop a new radio system that will be integrated into the NAS, allowing for reliable and secure communications. The human systems integration challenge is essentially a human factors challenge that will help configure uniform ground control systems and displays to enable ground station pilots to work effectively. And the Integrated Test and Evaluation Challenge will provide a relevant environment, which will allow researchers to integrate different components of the system and test them in a virtual environment, then into real test flights. Each one of these technical barriers have their own unique and challenging issues, but due to the complexity associated with integrating each of these into one system, NASA planners are working jointly on these issues to ensure proper integration.
If you know a little bit about systems, you know you can't take different elements of a system and you can exercise them and test them, but if you don't combine them into an integrated flow, you miss those little things and they don't really work well. So we don't want to just go out and have a lot of silo sub-projects. Those systems all interact and integrate within each other.
With this collaborative plan in place, NASA's 4 aeronautics centers are working jointly to make this goal a reality.
So the community working on unmanned aircraft systems is large. It includes Department of Defense, it includes Homeland Security, it includes a significant number of people from the FAA, and lots of people in industry working on standards. NASA has a relatively large hand in this also. We've got 4 centers working on it. Our 4 technical challenges are spread across those centers.
Let's first look at the Command and Control Challenge that is being led here at NASA Glenn Research Center. Here is NASA's Jim Greiner.
Before this project began, NASA surveyed the industry and other government agencies in order to determine what areas need to technology development for unmanned aircraft to be integrated. 2 of those areas were separation assurance, how to keep aircraft away from each other, and the other area was communications, how to make sure we had a reliable, secure communications link between the ground and the aircraft. So we worked with industry to develop the program that we're actually employing today. So what technologies we need to develop and the performance requirements of those technologies to make sure that those systems were robust and sound. So we have been working alongside industry in performing testing to enable those standards to be written for commercial entities to be able to certify equipment to put in unmanned aircraft.